Flight operations. As demonstrated by flight tests in icing conditions, the Embraer regional jet exhibits good handling and responsiveness and requires no special procedures in Appendix C icing conditions when operated in accordance with the AFM. However, safe operation of the aircraft in icing conditions requires preparation, coordination, and good situational awareness by the flight crew. The ice protection system must be checked once a day, provided ice conditions exist or are forecast. Review test procedures set forth in the AFM, as long as the complete set of normal procedures, and follow them. After the engines have been started and the ice protection test is performed, turn engine ice protection on. Wings and stabilizer ice protection will not operate on the ground, as excessive heat of the leading edges may cause structural distortion. Check the controls for freedom of movement and full travel. Operate all trim systems. If there is any restricted movement or jamming of any flight control or trim system, report this immediately to the maintenance personnel. Taxiing on ice, snow, or slush-covered runways should be done at the lowest practicable speed due to reduced braking capability and the possibility of skidding. Taxiing with flaps 9 degrees exposes the jack screws to contamination thrown up by the main gear. Therefore, always taxi with flaps up on ice, snow, or slush-contaminated runways. Flaps should also remain up with water on the taxiways and OAT is near or below freezing. Because of reports of anti-ice fluids remaining on the fuselage being carried into the APU inlet during takeoff roll, a new APU inlet shifted approximately 30 millimeters from the fuselage is being introduced by the Service Bulletin 145-4914. This new inlet has been flight tested and proved to avoid fluid ingestion. Until compliance with SB 145-4914, Embraer recommends that APU bleed not be used during takeoff following anti-icing fluid application. Don't forget to review the takeoff performance analysis to determine the appropriate weight and speeds for anti-ice on. Check for proper thrust rating mode. In a situation where field length and surface conditions are not optimal, use the rating mode that gives maximum thrust. Particular attention and proper assessment is required to cope with contaminated or low-friction runways. Shortly before the aircraft reaches the runway for takeoff, repeat the flight controls check and make a final visual inspection of the wing to ensure that it is clean. When inspecting the wing during a pre-takeoff contamination check, look at the entire upper surface and not just the leading edge or wing tip. Although the wing tips can be seen from the cockpit, almost the entire wing is visible from a cabin window. Therefore, it is strongly advised that a crew member make the visual inspection from the cabin. Additionally, the crew should ask for the assistance of trained and qualified personnel outside the aircraft to assist in the pre-takeoff check to ensure that the tail and fuselage, which are not visible from the cockpit or cabin, are free of any ice contamination. Remember that high winds and jet blast may cause anti-ice fluids to flow off, and other factors can contribute to reduce fluid effectiveness and reduce holdover times. If any ice has accumulated or the holdover time expires, never assume the ice will blow off during takeoff. Return for another fluid application and get de-iced or anti-iced again as the conditions require. Turn engine ignitions on during takeoffs on wet or contaminated runways to minimize the possibility of power loss due to spray ingestion or impingement. This recommendation is valid in areas of heavy precipitation and whenever there is the possibility of engine flameout during cruise and landing phases of flight as well. Take off in a normal manner. Rotation does not require any special technique. Once airborne, monitor pitch, attitude, and airspeed continuously with autopilot on or off. Performance changes such as airspeed decrease, reduced climb rate, and or higher than normal pitch angle may be an indication that ice has already accreted onto the airframe. If ice-related performances decrease are noted, ensure that all anti-icing systems are selected on and make the required thrust and attitude adjustments. Remember that icing in flight can occur at any time of the year. Therefore, it is necessary for the flight crew to monitor the systems and remain cognizant of ice anytime the airplane is in icing conditions, even in the summertime. The aircraft is fitted with an ice detection system to detect ice accretion and turn on all ice protection systems. Nonetheless, flight crews should remain vigilant and always monitor for icing conditions at total air temperature below 10 degrees Celsius. If icing conditions are present and the system has not been automatically activated, the flight crew should immediately manually activate the ice protection system. Visual observation of ice on the windshield pillars, windshield wipers, and wing leading edges is a clear indication that icing conditions are present and ice is accreting on the aircraft. Verify that the engine, wing, and stabilizer valves open lights are illuminated on the ice protection panel. Confirm that the cross-bleed open message has appeared. The bleed low temperature message may appear at low thrust setting, but should disappear rapidly once thrust levers are advanced. When total air temperature is below 10 degrees Celsius, the flight crew should also be alert for visual cues of unusual icing. If ice accumulation is rapid and severe, such that the anti-ice equipment fails to reduce or control the hazard, request immediate clearance from ATC and leave the icing conditions. Remember, unusually extensive ice accreted on the airframe in areas not normally observed to collect ice, or accumulation of ice on the upper surface of the wing aft of the protected area should be assumed to come from supercooled large droplets. Again, leave these icing conditions immediately if severe or large droplet SLD icing is observed. When clear of icing conditions, check that all ice protection systems have been automatically set to off. Unless otherwise required by the AFM, once the aircraft has exited icing conditions, the anti-ice system should be turned off. If the system is kept on out of icing, a no ice anti-ice on message will appear. The system is designed to reduce the workload of the flight crew in icing conditions, but it does not relieve the crew from monitoring the system and ensuring that it is operating properly. During descent, idle N1 when encountering ice will automatically spool up to maintain N1 required for bleed pressure. This can be compensated for by using all practicable means available, such as speed brakes and flaps 9 degrees. Do not use more than 9-degree flaps until established on final approach. Flight crews should be particularly vigilant if icing conditions exist while the aircraft is in a holding pattern. Remember that the minimum airspeed in icing conditions is 200 knots indicated. Flaps and gear must be retracted. Should severe icing conditions be encountered during holding, the flight crew must closely monitor the icing and take immediate action to exit the conditions. It is never good practice to continue to hold in icing conditions. Review all AFM data required to land in icing conditions. This requires reviewing performance information, associated speeds, and special procedures for landing with a failed anti-ice system. Landing on runways contaminated with ice and slush requires that flight crews plan and execute the approach and landing properly to be successful. It is essential that the aircraft is configured and stabilized to passing 1,000 feet AGL. Crossing the runway threshold at 50 feet and VREF will place the aircraft within the 1,000-foot mark. Touchdown on the center line to provide maneuvering margin if the aircraft starts to drift because of runway surface contamination, and lower nose wheel immediately. Apply brakes symmetrically. Apply thrust reverses judiciously to observe how the aircraft responds before full reverse is used. Normal procedure is to move the thrust levers out of reverse when ground speed is reduced to 50 knots. In an emergency, reverse thrust may be used to bring the aircraft to a full stop. In extreme cases, the aircraft may continue to move with brakes locked, even with idle thrust. If no deceleration is felt, do not use emergency brakes, as it may cut anti-skid protection and may cause the ground spoiler to close. Keep pressure on the pedal brakes and use reverse until the airplane decelerates. Continued use of reverse until the aircraft comes to a complete stop may be necessary in extreme cases. After landing on a contaminated runway, or after operation in icing conditions, flap retraction from 22 to 0 degrees should be delayed until they have been inspected and confirmed clean of deposits of ice or slush. That's it. Successful operation in icing conditions requires preparation on the part of the flight crew and ground support personnel. Be prepared to respond to icing conditions and review all available material and all information that can assist you in making practical and safe decisions. Continuous flight crew alertness to the meteorological hazards and the effect of contamination on aircraft performance is essential. Rigorous adherence to the clean airplane concept is essential, and of course, flight crews should be familiar with applicable portions of the flight and operations manuals. Advanced preparation and situational awareness by flight crew will ensure that safety is maintained during all cold weather operations, and especially in icing conditions. Fly safely.